All right, gang, the next section that we're going to work on are parallel and perpendicular lines. So I've drawn two parallel lines here on the board, and there's something that happens with parallel lines that is quite important. First of all, two parallel lines are parallel because they never intersect, they never cross each other. So they're always moving in the direction up and over with the same rate of change. Rate of change can be another word for slope. So when I look at these graphs, for every 2 I go up, I go over 3. Up 2, over 3. Up 2, over 3. Now, you'll see that if I'm on the bottom graph, if I go up 2 and over 3, I'm at a point on the line. Up 2, over 3, I'm at a point on the line. Up 2, over 3, I'm at a point on the line. So there's a significance here that these slopes are the same. So what's important here is parallel lines have exactly the same slope. So when we go to write equations of lines and we're given the equation of a line and a point on another line, we can find the equation of that other line because we know parallel lines have the same slope. So I'm going to do a couple examples like that on this front board. All right, problems 43 through 62 deal with either parallel or perpendicular lines. So first we'll look at parallel lines. So we'll do number 43. Okay, it says find the equation of a line that is either parallel or perpendicular to the equation that's given. So we're given a point 0, 2 that has to be parallel to y equals 1/5 x. Okay, so there's a couple things that we know. This equation has a y-intercept at 0. So I know this equation is going to go through the point 0, 0. It's going to go up 1 and over 5, up 1 and over 5, up 1 and over 5, forever and ever and ever. So what I know is that since parallel lines have the same slope, I'm going to use this slope to find the equation of a line parallel to it. Okay, so basically we're going to be doing the same thing that we did before. We just use the knowledge of this slope to help us find that other equation of the line. Again, y equals mx plus b. Never goes away. So, what I'm going to do, I'm going to take this slope. I'm going to put it in here for m. I'm going to use the point that I'm given and put those values in for x and y. This is my y value. This is my x value. So I'm going to put in a 2 for my y. I'm going to put a 0 in for my x. And I'm going to find a b. Well, problems like this are awesome because when I take 0 times anything, I'm going to get 0. So that just means my b is 2. When I go to write the equation of the line, I'm going to use this slope, and I'm going to use my new b. Oops. Easy peasy. All right, so we'll do another equation. Because, of course, they're not all quite that easy. Let's see. How about we try number 45? We're going through the point -3, 4, and we're trying to find a line that's parallel to y equals -4/3 x plus 1. Okay? The only information that we need from this equation is the slope. Okay? I want to find a parallel line. So I'm going to use negative 4/3 as my slope. Go to y equals mx plus b. Take negative 4/3, put it in for m. We're going to take 4, and we're going to put that in for y. We're going to take a negative 3, put that in for x. Okay, remember this is negative 3/1. If I'm multiplying fractions, I can reduce here because 3 goes into negative 3. And you don't lose that negative sign. We're going to see that as a negative 1. So I end up with 4 equals a negative 4 times a negative 1 is positive 4. So now I subtract 4 from each side, and I get a b value of 0. Okay, when I get a b value of 0, that means this line goes through the origin. It goes through the point 0, 0. This is my y-intercept. So when I write my y equals mx plus b, I'm going to take this slope, I fill in my y and my x, my b is 0, okay? I could write that in, but we don't really need to write in a 0 because it's understood if it's not there. So the final form of the equation of my line is y equals negative 4/3 x, okay? If I graphed this, it would be parallel to this line, and it would go through this point. So let's look at perpendicular lines. As you know, a perpendicular line forms a 90-degree angle. So if we look at problems 53, we're going to have a point 40 and a line of y equals negative 2x minus 1. So what's really important to remember about perpendicular lines, okay, we're going to find a perpendicular line. Oh, this marker's terrible. Okay, we're going to find a perpendicular line to this one, but it has to go through this point. Well, the important thing to remember is that perpendicular lines have negative reciprocal slopes. What's that mean? Negative reciprocal slopes. Well, here's some examples of reciprocals. Before we get into the problem, let's talk about that. If I have the fraction 2/3, the negative reciprocal is I'm going to flip the fraction and I'm going to change its sign. Simple as that. If I had negative 2/5, the negative reciprocal is going to be, I'm going to flip that fraction and I'm going to change the sign. So in this case, it's 5/2. The thing about reciprocals is that all you do is you flip them over to get the negative, change the sign. So let's work on our problem. I have this line y equals negative 2x. So I'm going to identify the slope here. The slope of that line is negative 2x. I need to find the negative reciprocal slope first. Okay, so I have to see this negative 2 really as a negative 2/1. Then when I go to find the negative reciprocal, I'm going to flip that fraction and I'm going to change the sign. So my new slope, to find my perpendicular line, I'm going to use 1/2. So back to y equals mx plus b. And the routine's the same. We do the same thing all over again. I'm going to take this slope and I'm going to put it in for m. I'm going to find a b. I'm going to use this point. I'm going to put a 0 in for y, because that's my y value. And I'm going to put a 4 in for x. Half of 4 is 2. I'm going to subtract 2 from both sides. So my new b is a -2. Now when I go to write the equation of my line, it's quite simple. Y equals this slope plus or minus, as this is a negative, so I'm going to write it as -2. Okay, if I graph y equals -2x minus 1, and on the same graph I graph y equals 1/2 x minus 2, they're going to be perpendicular. They're going to cross and form a 90-degree angle. So let's do another one. Let me find a problem. Let's skip down to number 59. We want to go through 4, -5, and be perpendicular to y equals 1/2 x minus 2. Okay, so let's remember, my very first thing is find the negative reciprocal slope. So, my new slope, I look here, I take this fraction, I flip it, and I change the sign. If it's positive, my negative reciprocal will be negative. Well, since we're big boys and girls, we don't write it over 1. We're just going to say my new slope is -2. Back to the good old y equals mx plus b. I'm going to take this slope, I'm putting it in here for m. I'm going to take this y value, put it in here. I'm going to take this 4, I'm going to put it in for x. So I have -5 equals a -2 times 4 is -8. I'm going to add 8 to both sides. I find out my b is 3. And now I can write the equation of my perpendicular line. I use this slope, I use this b, and I'm done. Okay? So you have to remember the process that you go through to figure out whether you're working to find a parallel line or whether you're trying to find a perpendicular line. Okay, one more thing to address is what happens if they give me something that has a slope of 0 or something that has an undefined slope. So let's do 2 more problems and we'll look at those. All right, suppose I'm given this. I'm given a point of 5, 7, perpendicular to, oh, not that. We're going to give you a line first. Y equals 7. I want to know what is the equation of the line perpendicular what is the equation of the, no, what is the equation of the line, sorry, perpendicular to y equals 7. So what you have to remember is y equals 7 is a horizontal line. Okay, so let's think about the picture that we get. 1, 2, 3, 4, 5, 6. Okay, here's the line y equals 7. Okay, it's got to go through this point 5, 7. Change colors here. Well, there's only one line that could exist that's perpendicular to this one, and that would have to be a vertical line. Okay, so what's the equation of this vertical line? Well, what's my x value? 5. Okay, so the line that is perpendicular to y equals 7 is the line x equals 5. Okay, if I had been given this in reverse, suppose I was given an x equal equation, basically we're going to do the same thing. So suppose I'm given a point of 1, 4, and the line that I'm given, not y, sorry, is x equals 1. Well, again, I'm going to think about the graph of this. You don't have to draw the graph. I'm drawing the graph so you can visualize what's happening here. The line x equals 1 is this, this vertical line. Okay, this graph needs to go through the point 1, 4. Got to go through this point, and I'm looking for a line that's perpendicular to it. The only perpendicular line to a vertical line is going to be a horizontal line. What's the equation of that line? What's my y value? Y is 4. Okay, and that should wrap us up on finding equations of lines.